will talk about emerging Earth observation technologies to support any activity on Earth surveillance. So how we go from scientific data, observational data, but socioeconomic data to knowledge to support the policy making and the policy decision processes. So we have this webinar this afternoon that really will provide an insight, but the scope is to raise awareness to decision maker community on the contribution that Earth observation in producing knowledge from scientific observation, how this can support the analysis of a number of issues that are directly or indirectly linked to chemical pollution and vector-borne disease. So the focus of today's webinar of this showcase in general is really to provide tools that are user-driven, user-friendly, and policy-driven to improve the policy process and support the evaluation of the effectiveness of measures that nations and countries have implemented to achieve the goal of international convention. In specific, we will talk about the Minamata Convention for Mercury and the Stockholm Convention for Persistent Organic Pollutant, and then also to contribute to the implementation of the GEO work plan. As you know, GEO is the Group on Earth Observation, and there is a work plan that is implemented through various different flagship and the GEO initiatives, and the one that are on which we focused our attention is the flagship on Mercury, the GOOS4M, and also the initiative, the GEO initiative on POPs. Then, of course, another important focus is to provide high-quality satellite-derived information on air quality in urban environment and give solution to detected issues. As we know, urban environment are under pressure for air quality, very often for poor air quality and for increasing population pressure, water demand, and so on. And then the last but not least is to support the European Union decision makers with a roadmap to build integrated yearly warning system for vector-borne disease. So the showcase that today we will present the major outcome in terms of tools. The goal of this showcase, the overarching goal, was to demonstrate the incredible value of Earth observation data in elaborating strategy for surveillance of environmental pollution and public health in cooperation or as part of the Group on Earth Observation. And it was aimed, this showcase, to contribute, as I said, to the flagship on Mercury, the initiative on POPs, and also the Earth observation for sustainable development goals with a set of key enabling technologies. And also recently, a new pilot was added, was taken on board in this showcase dealing with the health. So how Earth observation can support the development of technology tools for specific health issues. You will hear more about this later. And then each pilot developed application as web services that can allow end users to get advantage of data, scientific knowledge, scientific observation, advantage for decision makers. So specifically the four pilot and the leader of this pilot, you can see reported here. So we have a four pilot, one on Mercury, one on POPs, one on pollution health risk profiling in the urban environment, and one on this yearly warning system for mosquito-borne disease. So now we have also a video that will introduce a broader audience to the eShape project. So we will try to launch this video. It's just 4 minutes, so not very long. And then we will start following our agenda that you see reported here. So we'll start with the pilot number 1 on Earth observation-based surveillance of mercury pollution that will be presented by Sergio Cinirella, and then we'll follow with POPs pollution by Lucas Pokorny, and then we'll follow Eleni Athanasopoulos from NOAA in Athens, to end with the Konstantinos Tsapralis talking about this yearly warning system for mosquito-borne diseases. Then we will reserve some time for question and answer and open discussion before we close this webinar. So go ahead, Sergio. You are the first presenter.
I guess now you can see.
Yes,
in presentation mode.
Yes, now we can see it.
Yeah, okay. I'm the leader of this pilot in eShape. Of course, behind me there is a number of co-workers that I would thank. They are Maria Antonia Bencardino, Delia Bruno, Francesco D'Amore, Francesco De Simone, Ian Hedgecock, of course Nicola and Francesca. And new researchers are being involved on the health part.
Sergio, you are not in presentation mode, by the way.
Now? Is it presentation now?
Yes. Yes.
Yes, okay, thank you. So this pilot is aimed to support the GOOS4M flagship, the Global Observation System for Mercury. You can find more details on the website of the GOOS4M. But a few things I can say that are the flagship is aimed to support the UN Global Partnership on Mercury Effect and Transport Research by providing a global data set of monitoring data on atmospheric mercury, marine measurement, and also on measurement on board aircraft. So it would increase the existing regional and global scale network monitoring data. It is providing now, is a reality, it is providing a knowledge hub that integrate Earth observation data set and modeling tools that can allow the co-design of policy-driven scenarios. Of course, at the end, the effectiveness of measures undertaken by the Minamata Convention can be assessed. Few key aspects of the knowledge hub that is being implementing under the pilot. The Knowledge Hub is an integrated multimodal and multi-domain computational platform, of course, to support the effectiveness evaluation of the convention. Actually, it provides a data infrastructure with shared data that follow the geo data sharing and management plan, a chemical transport model emulator to simulate the position scenarios over land and ocean, an integrated biogeochemical and trophic models to simulate long-term trends of mercury concentration in ocean and the biota. We share also application programming interfaces, and the Knowledge Hub enable scenario analysis. Few words on the scientific evidence and the co-design approach that we have used to develop the Knowledge Hub. Of course, each tool that we have developed, you can see the tool later. Each tool has been published, so there has been a peer review behind the tool. We also published a few technical reports and also having feedback from stakeholders. And now we are trying to have a feedback from parties and end user on the application. Now, inside the Knowledge Hub, the Knowledge Hub is provided as tools. Each one is a widget that is a very simple from the side of the end user, is a simple component that provide complex application on the side of the producer. So the widget on the anthropogenic emission provide mercury emission maps. This is a tool to visualize global mercury emission by country and by source. Of course, data are based on the most recent mercury assessment. The last one was published in 2018 by UN Environment and AMAP. A second widget is on monitoring data. This is the core of the Knowledge Hub, because we provide data through, of course, metadata. We provide data of mercury concentration in air, marine water, and atmosphere. Data can be explored, plotted over map, but also downloaded. Downloads can be done through different formats, as you can see on the left corner of the slide. We are actually providing data coming from the GMOS program, but also we are working to provide access to regional networks from like those of AMAP, like those of Canadian network and American monitoring network. One widget is based on scenario. Here there is a long work behind, because as most of you know, models are very complex to run. A simple user, an end user cannot do this work, but we have developed this tool to provide outputs of models which are based on different inventories, and outputs can give the ability to the user to change anthropogenic emissions, so to perturbate emission in order to define, to test its own scenario. Actually, we are providing results from one model and one inventory, but we are working to provide different models and different inventories to make this more useful to the end users. If a user wants to understand how it runs the emulator, he can move the cursor and reduce the emission from a region. and the change is provided through tables. I can show you in the next slide how it can run the emulator. Of course, in each region we have different sectors that are contributing to the emission. The users can also play with different sectors to reduce the emission, and it has the result of a reduction for each sector, but also as a whole. After having changed the cursor, the position are provided as number or plots. Result of the simulation can give you global deposition over lengths, over different lengths, over different regions, but also over different oceans. Colors indicate the statistical significance shown in each region. Of course, a comparison against the business as usual scenario is provided for both lands and oceans through plots. After the widget on the deposition, the result of that widget are ingested by this biogeochemical model. This is a 6-box biogeochemical models. All information can be found on the website, and references are also therein. The model is run in near real time. It gives mercury perturbation in the ocean, and it gives trends on a long term. So the range is 1 to 30 years. Deposition and concentration, of course, include also natural but legacy sources. The biota model, also connected to the biogeochemical model, gives concentration in biota calculated as a percentage variation in respect to the current value. All data can be downloaded, can be plotted, can be shared. We are in a Creative Commons license. We contribute to the GeoPortal and the GeoKnowledge Hub. Details are provided through the Goes4M website. Here you can see 2 screenshots, one on the GeoCommunity portal, on the Goes4M community portal, but also on the right side you can see the GeoKnowledge Hub, to which we are providing information. Forthcoming tool. This has been developed, but is not yet deployed on the system. We have done a tool. We've developed a tool to provide cost estimate for different scenarios. On this screenshot, you can see, for example, that if you change the reduction as a percentage of stationary combustion, you can see the average cost, because we have the lower and the higher estimate of this cost. We are also working to this one, that is the human health risk assessment that is based on level of mercury in fish and fish consumption. We are collecting data mainly on fish consumption. I guess that this will be available in 2 or 3 months, not before, because there is a lot of work behind data collection. So I stop here. I would thank you and leave the screen again.
Thank you, Sergio. Just on the top of what Sergio said, this knowledge hub for the mercury out of the going to the web portal of the flagship, and you can have, you can test different emission reduction strategies, scenario, just what Sergio has been showing, and you can generate by yourself the curves of mercury bioaccumulation in fish and so forth. Of course, the aim is to improve this and having other atmospheric model running. For example, right now the global model is only one available, ECMERIT, as part of our system, but very soon will be available also geoscam simulation. So the end users can select what type of a global model wants to use, and the same will be adopted as approach also for other segment of the knowledge hub, like the biochemical model. Hopefully we'll have a second one, and so on. And then very importantly will be the cost estimate. That is what is really needed to policymakers. So for different emission reduction strategy, you need to provide how much would be the cost, on which time interval, and what could be the payback in terms of gaining and benefit. So I won't take any more time, and I ask Lucas to introduce similar work done in pilot 2 on persistent organic pollutant. Please, Lucas, the floor is yours.
Thanks, Nicola. And good afternoon, colleagues. I'll share my screen. Can you see the presentation well?
Perfect.
Yes.
Yes.
Okay, perfect. So good afternoon, colleagues. My name is Lucas Pokorny. I work for the Recetox, which is an institute for toxic compounds in the environment at the Masaryk University in Brno. And today I will tell you about the pilot falling into the showcase number 2. The pilot's name is EO-based surveillance of pop pollution, S2P2. And in the presentation, I will focus on the pilot's main goals. I will touch upon the updates and main features of the updates that were carried through in terms of the eShape project, and then I will show you how the pilot is contributing to generating knowledge and influencing decision-making on global, regional, and national level. And because it's currently, at this moment, there is a conference of parties of the Stockholm Convention that this pilot supports going on in Geneva, and on Monday we had a launch of the third round of the of our pilot. So I will speak about it later. So what are the main goals of the pilot? it is the global repository of persistent organic pollutants data in 4 main matrices: air, water, human blood, and human milk. And the basis of the pilot is the global monitoring plan data warehouse, the GMP data warehouse platform and web service. One of the main goals is, of course, to support implementation of the Stockholm Convention and also of the Convention on Long-Range Transboundary Air Pollution. And among the other goals, of course, enhancing exploitation and use of Earth observation in situ derived information on POPs. It's important to highlight that the data that we use are gathered in situ. So these are in situ data that we are using from around the globe. And of course, part of our mandate and big part of our mandate is also to deliver data on POPs to decision makers, also, of course, via the Geo portal, and then bring synergies through collaboration and integration of persistent organic pollutants network activities and schemes, because in our pilot, we collect data from also various different global networks that focus on POPs. GAPS, EMAP for the United Nations Environmental Commission for Europe, for the CNR-IIA Convention. We have also a network for the Latin Caribbean, Latin American, Caribbean, etc., etc. So we are building on delivering data to policymakers so that they can influence what's going on regarding POPs in the world and on the regional level as well. And of course, then synergies between the networks that are scattered around the globe. Specific goals. Of course, it's in line with the Stockholm Convention's mandate. It's to increase the availability and quality of information that are needed to track persistent organic pollutants, and then to actually evaluate the effectiveness of the convention. Because without the data, we don't know what's going on, and we don't know how to evaluate the implementation and the effectiveness of the Stockholm Convention. And of course, anticipating changes in the global environment. I will show you then later on through the main outputs that we deliver to policymakers, how we actually help to anticipate these changes in the POPs area. And of course, a tool rather than a goal is developing advanced web services that parties, but not only parties, also academia and but also general public, government officials may use to support the effectiveness evaluation of the policy mandate of the Stockholm Convention, but also, of course, to gain knowledge about how persistent organic pollutants are influencing or impacting their lives. And of course, in terms of Geo, we closely interact with the GOS for Health initiative, and we already linked the DMP3 data to Geos. It's important here to mention that we just finished the third round of collection of POPs data last November, and the outcome was approved, as I said, at the Conference of Parties this week on Monday. So it's publicly available, and everybody can have a look at it, use it, and draw conclusions. And within the Geo community, we have just submitted the proposal of the initiative GOS for POPs for the working plan 2023-2025. Very briefly to main users, guidance that we use, and partners. Users, of course, I mentioned already Stockholm Convention and the Convention on Long-Range Transboundary Air Pollution, policymakers, governments, industry, NGOs, and of course, last but not least, scientific community, very important stakeholder. Key document. Our work is pre-described by the guidance for the global monitoring plan, because we, in the end, we are accountable to the Stockholm Convention and to the parties, better said, to the parties of the Stockholm Convention. So the guidance defines the scope, core media, defines sampling procedures and analytical techniques. It is updated regularly, And what concerns our main co-design partners, these are the regional organization group. They are structured, or they are formed around the United Nations system. So we have the regional organization groups that fall into the classification of the United Nations. And they, of course, they are our main partners. They are there for the data inputs. They fill data gaps. They prepare regional reports, validate data, etc., etc. So we are in close touch with them, especially in the where we are coming close to the publication of the data. And here you can see the official launch of the GMP data warehouse content of the pilot, with Kateřina Šepková sitting at the in the right down right corner. She's the main person behind our pilot, with my colleague Richard Hulek and of course Jana Klánová. And this week the output of the outputs that I will show you later on were approved by the parties of the convention. So we fulfilled our task and are getting ready for the fourth round of monitoring of gathering the data. General observation. I spoke about the only thing that I will highlight here is the specific kind of background of our pilot. We are always walking the line between science and policy, because we are accountable in the end to the parties of the Stockholm Convention, and of course we are trying to also to make our pilot as effective as possible, and as user-friendly as possible, of course, with limits that we have to take into account. And the GMP data warehouse was first published or first established in 2012, and is being updated periodically since then. Available now with all the information from GMP3, from the latest round of data collection, is on the link that is at the bottom. So here, very briefly to show you a few snapshots of the work of the website, where you can then have a look and see what's in there. I'll just walk you through very quickly what's available. So in terms of content, I mentioned the 4 core media. We have data on 30 listed chemicals, because annex of the Stockholm Convention is now listing 30 chemicals with 314 chemical parameters. I talked about the monitoring networks, and we have stations in 127 countries with date range from the 1967, of course, scarce data, but first data sets originate from 1967. On the screen, you can see with colors the monitoring stations by region, with colored differences, and the blue spots in the oceans are the cruises that also from which data were collected on POPs in water. For the data visualizations, we improved in the last 3 years while working under the IIA. We improved the data visualizations so that they are easily accessible, and we have spatial distribution, data availability, summary statistics, trends analysis, and data exports modules, which you will now see in the following slides. What concerns the kind of an innovation, and it was a direct request by the regional organization groups that I mentioned as our main co-design partners, is the data management console. It was introduced primarily for import of data. It's accessible only for authorized users that are defined or identified in the regional organization groups. It's of course online web tool, and it has a feature where the responsible persons have approval management features available. So it's we meet in person unfortunately, it was not possible during COVID, so we had many video conferences, but the approval process happens online. Summary statistics, and this is just a quick walk through the modules. So here we can see the summary statistics module, where you can filter multiple sites or single sites and select those 314 parameters. We have trend analysis models. Again, you can have multiple sites on a map or detail on a site here. I will just give you an example of an upcoming priority substance, the PFOS. These are the latest conclusions from the presentation that was given in Geneva. So you can see that there are differences in respective subregions, but it's very important to say that the tool is dynamic, and it can absorb those substances such as PFOS that are identified as an emerging risk, and it can include those data also in our tool. What concerns our work with policymakers or science policy interface, it's very important to mention regional reports that actually draw heavily, if not uniquely, on our pilot. It's the main output are the regional monitoring reports, already all regions covered already. The global monitoring report just was approved in Geneva. So these are reports that include, of course, conclusions based on the evaluation or based on the data that we provide, that the policymakers are provided by us. So you can see this is the excerpt from the regional report for Africa, where you can see the conclusions. Africa being heavily impacted by especially persistent organic pollutants from pesticides, and of course other issues that need to be solved. And the next step actually is just happening in Geneva, where policymakers, usually ministers, usually high-level ranking policymakers come to Geneva for the conference of parties. They are presented these reports, and then these reports serve as a basis for the decision making for further regulatory work. So we can see direct policy impact based on our work. So conclusions. I already spoke from science to policy. And our pilot, I explained how this gets translated, how the data get translated to policymaking and regulatory work. Sustainability of S2P2 are also mentioned, that the guidance is regularly updated, and we will receive guidance from the parties to the Stockholm Convention, how to actually move on with the pilot, what is needed, and of course here on the more working level, the regional organizations groups. And one of the main goals that I described also earlier was advancing services for users, where we need to make sure that our pilot works both ways, works towards the academia and works towards as well policymakers. So thank you very much, and back to Nicola.
Thank you, Lucas. Thank you. A lot of work has been done also in this pilot, and I'm sure that the Stockholm Convention is getting a lot of benefit from it. And so the next speaker is Eleni, that will talk about risk-related human health related risk for urban area. So Eleni, the floor is yours.
Can you see my screen?
Yeah. Presentation mode, please.
Mm-hmm.
Okay.
Is it okay?
Perfect.
Okay. So hello from Greece. I work at the National Observatory of Athens, and I support the coordination of the third pilot of this showcase. The principal investigator is Evangelos Gerasopoulos, and I'm also responsible for the numerical atmospheric modeling activities in the frame of this pilot. And I will give you some insights and a short demonstration of the current status of the outcome of this pilot. So the name of it is EO-based pollution health risks profiling in the urban environment. And what we have done, of course, in alignment with the objectives of the Holy Safe project and also of the specific showcase, is to combine Earth observation from different platforms, in situ stations, satellite retrievals, models, and citizen science, which are fused then with population data and health-related data towards added value products that can support public air quality and health assessments, informed decision making, and urban planning. So for those who have been following the activities of this pilot from the beginning, you may remember this scheme, which is the representation of the schematic representation of this pilot. Although now the components are more than initially designed, and I am here to show you 5 of those 7. It remains as to be online this thermal pollutant human comfort that currently I process the data for select European cities, while the citizen science campaign in Vienna from the EASA partner is still pending. So the service is, the teaser platform is actually online and accessible. You can see here the link, and you can also see here how it looks like. So as you can see, around 50 cities in the globe are here to provide some data related to air quality and human health. And the different colors you see here are relevant to the different components of this teaser. As we have all of us said up to now, the users are involved in the process. They uptake the information, but also they have participated in the co-design of these products. In the case of this pilot, you can see here that the stakeholders are grouped in 4 categories. While you can see also the organizations that take part during the formation of the pilot, as well as they uptake the outcome. You can see several organizations from all the participating countries countries in the pilot. So to begin with, for the city of Munich in Germany, there is an assessment of health risk due to air pollution. Here you can see an insight of the outcome. So you see that the health risk that is calculated is dependent on the hazard, which is the pollutant concentration, and comes from a multitude of platforms. Then the exposure that is related to population density, the urbanization level, and the time patterns of the activity of the population. And on the bottom right, you can see the sources of this data, but also is dependent on the vulnerability, which come from international health authorities, as well as from data from epidemiological studies that are available in literature. So here you can see a short demo of how the teaser platform looks like when we enter the city of Munich. So the spatial disaggregation of information is very high. We can see the aggregated risk index for each polygon represented by the same zip code of the city. We can see maximum and average values of this risk for a 4-year period. This application can be replicable to other cities as well. while all the information that is behind this data, as well as information on the procedure, can be found in the platform. You can see at the rectangle at the top left, which, as I said, compiles all information. Actually, the air quality health aspects are also given for several megacities as defined by the UNESCO. In this case, this index is calculated for around 50 cities at the moment. And I have to say that the risk is not dependent only on one pollutant, but actually on the mixture, on the atmospheric mixture composed by by 5 different pollutants. So here, again, if one selects one of the red or green cities, which are the present megacities and the projected ones for the futures according to UNESCO, then can study the trend of this index. For Athens, we have worked with a model system that you can see here. The main modeling tool is an urban scale chemistry transport model that takes inputs from Copernicus CAM service, both for the air quality boundary conditions and the emissions, which are then spatially disaggregated towards high resolution emission fields with a tool we have developed at NOAA. These predictions are assessed through all available in situ measurements, and then we produce health-related outputs that are currently demonstrated as you will see in the moment. So we have provided population exposure to NO2 and PM2.5 for a whole year on a monthly basis, compared to the values of the monitoring stations, while at the moment we are calculating the European air quality index, as well as health relevant information for population when pollution is compared to the latest WHO limits. This will be uploaded soon in the platform. For Helsinki, and actually for more than for many cities of Finland, the industrial footprint on urban air quality is assessed. Retrievals from the satellite Tropomi NO2 are converted into surface concentrations. Then this information has so far contributed both to the report of the ministry to the EEA with respect to air quality, as well as to the air quality and sustainability reporting of the company that owns refineries in a city at the east of Helsinki. And again, data are indicatively shown for Helsinki here. So we can see NO2 retrievals both from the troposphere as well as converted to the surface, and provided together with the industrial sites and the air quality monitoring station data. While for the whole cities that this analysis has been performed, the platform is shown on the top right. And the last component that was lately introduced in the platform is for Bari in Italy. And there the group addressed the UN SDG indicators. Here we see a schema on how the population map is created in a high resolution in the city. And then they proceed to the calculation of the relevant indicators of goal 11, which is the urban SDG. So here one can see again that when focusing on Bari, model outputs, either from PM10 or from PM2.5, that one can say are less attractive for a policy maker, a decision maker, when combined to the population density, high resolution population density, actually they give the added value product of the SDG 11.6.2, either with respect to PM10 or PM2.5, which means that then the decision maker can know the hotspots of the city and can take targeted measures. That was all from me. Thank you very much.
Thank you, Eleni. Thank you so much. Very interesting. Also here, a lot of work, and I'm glad to see that a lot of work done also in Planet, another program that we have been working together, has been very well used in eShape to empower all this activity. So the next speaker will talk about vector-borne disease. So this is a new pilot that we included not a long time ago. So we have Konstantinos, still affiliated to NOAA, so from Athens again. So we'll talk about this very important vector-borne disease, very important topic, all things considered, as a post-pandemia. Hopefully he's post and not coming back again. But please, Konstantinos, the floor is yours.
Thank you very much. Let me quickly share my screen. Can you see it? Hopefully.
Yes.
Okay, very good. So, hello everyone. My name is Konstantinos Tsaprailis, and I'm the Technical Project Manager of the Early Warning System for Mosquito-Borne Diseases, or the EIWA. So, before we start elaborating about the EIWA system, let me reflect on the challenge that we set out to address. In the past decades, climate change, globalization, and other drivers are altering the ecological conditions for mosquitoes. Globally, mosquito-borne diseases such as malaria, dengue, and yellow fever, and Zika are present in over 100 countries in the world. Each year, they are responsible for almost 700,000 deaths globally. Malaria, which represents more than half of these, is tragically most lethal for kids under the age of 5 in the sub-Saharan region. But Europe is also a hotspot of West Nile virus, having experienced outbreaks in multiple countries in the past decade. Local expansion of chikungunya and dengue fever has also increased by over 40% compared to the 1950s baseline. So, the need to confront, control, and foresee this continuous threat gave birth to the EIWA early warning system. The EIWA system, developed in the context of EuroGeo, is the outcome of a 3-year voluntary action with the ultimate vision to introduce EIWA as a key tool to the epidemic's arsenal and to contribute significantly to combat and control mosquito-borne diseases. It's an state-of-the-art tool for the aversion of human cases in thousands of villages in the European territories via vector control actions and targeted door-to-door awareness campaigns. The EIWA project combines and distills information from diverse domains of expertise: Earth observation, advanced epidemiological and entomological modeling, artificial intelligence, and machine learning, as well as big data analytics. The early warning system has been operational since 2020, and in 2021, it supported 10 regions in 5 European countries. And in the end of 2021, as it was mentioned, EIWA was successfully onboarded as a pilot to the ESA project with a goal to bring the operational services in non-European countries, specifically in Cote d'Ivoire in Africa and Thailand in Asia. The outcome of the project in general was such a significant accomplishment that EIWA was awarded the first European Innovation Council Horizon Prize on early warning for epidemics, being a prime example of the unlimited Earth observation power and the societal benefits that can derive from harnessing space technology. So, the EIWA project consists of an interdisciplinary group of 15 partners for 5 countries, assuming roles in the domains of mosquito surveillance and control and in veterinary medicine, and also cross-cutting roles for big Earth observation data manipulation, predictive modeling based on data and mathematical processes, and decision support systems and platform development. EIWA's strengths are the highly skilled scientists with a record of more than 200 scientific publications in their fields. So I would just like to mention that this is the whole network under the E-shape. 3 of the partners from the 15 partners joined forces, the Beyond Center of NOAA, the Laboratory of Atmospheric Physics from the University of Patras, and the Bernard Nocht Institute of Tropical Medicine. We joined forces to make this expansion to the new regions. So, in general, besides the partners, EIWA engages more than 40 stakeholders at a European and global level, providing essential data and feedback. For instance, stakeholders from the USA, Brazil, India, and more. The EIWA consortium signed an MOU with the European Commission's Joint Research Centre to further advance the collaboration towards the common goal of expanding and exploiting the innovations in the early warning forecasting systems. Furthermore, it is being considered to provide support to the European Health Emergency and Response Authority of the European Commission. Last but not least, EIWA reaches out through participations in the GeoHealth Community of Practice, the Geo and Eurogeo Symposium, the GeoCradle Initiative, and the EO4Geo community. EIWA, as already mentioned, was onboarded as a pilot to the E-shape project with the ultimate goal of expanding the support of the service to non-European territories, specifically to Thailand and Cote d'Ivoire. And the main focus is to expand the database that we have of entomological data and train and adapt the models that we already have working on the European countries to new regions with different climatic and socioeconomic conditions, but also strengthen the models and help make an impact to the people in these regions by supporting on-the-ground awareness campaigns. So let me quickly say what are the EIWA system models. There are 2 types of models that provide predictions in EIWA, West Nile virus risk and also mosquito abundance models. The Mimesis and the BAR models are West Nile virus risk models. They provide risk maps of pathogen circulation on a municipality and on a settlement level. They provide predictions for 4 regions in Greece and 1 region in Italy, and will continue to expand to the new regions. They support supplementary preventative actions such as more intense larviciding where it is deemed appropriate. They also provide help in implementing door-to-door campaigns and raise awareness for the people in living in these settlements with increased risk. And in 2021, more than 31,000 households were reached in the Central Macedonia region of Greece alone. The bad mosquito abundance models, it works on a settlement level. It's available in Greece and soon in more regions, and it powers the mosquito vision mobile application. We used more than 2,400 villages in Greece, sending out notifications for high nuisance and also getting crowdsourced feedback. And last but not least, the Mammoth mosquito abundance model, it works on a trap level, providing mosquito predictions. It is available in 4 European countries. It was available in 4 European countries in 2021. It has also expanded to Greece in 2022, and it is also expanding to the new countries under the E-shape expansion. Why use the Earth observation in this specific field of health? Let me share some findings from the initial paper that was conducted by the EIWA team. Most of the environmental variables, geographical, climatological, and hydrological, that influence the transmission cycle of mosquito-borne diseases between pathogenic agents, vectors, and intermediate hosts, They can be monitored efficiently from satellites that carry specific instruments capable of capturing these parameters, these climatic and geographical parameters, and they can capture them frequently and on a global scale. Specifically for the West Nile virus, it was found that the variables with the most statistically significant correlations, either positive or negative, are the temperature, the rainfall, the site elevation, the normalized difference vegetation index, and the land use on these regions, specifically when there are irrigated crops and when there are forests that are populated. So how does EIWA leverage this vast amount of data generated by satellite Earth observation? By combining the in situ entomological and epidemiological data with processed Earth observation image data from the collection sites and the regions where cases are registered, augmenting them with socioeconomic, meteorological, and geomorphological data to create large time series that are fed into the models. 36 such different statistical features are generated for each of the 39,000 mosquito collections and counting. This is continually increasing in our database, creating a mammoth, if I may say, feature space of more than 10 years of time series data. And also I would like to mention that these generated features, the Earth observation features, they are opened and disseminated through the NextGeos platform. Unfortunately, due to IP constraints, the in situ entomological data cannot be opened, but all of the rest of this large amount of information, it is opened. Let me quickly say some of these features that the models use and what they are. The models are using 4 normalized difference indices for vegetation, for moisture, for water, and for buildup. They are features based on meteorological data such as wind, land surface temperature, and rainfall. Also, geomorphological data such as the elevation of the site, the aspect, and the slope. And also other composite features related to the proximity of the trapping sites, to mosquito breeding sites, to water treatment facilities, to water bodies, and many more. So how is this information disseminated? The system produces monthly reports which contain maps with the risk of human cases of West Nile virus and maps of mosquito abundance. Here you can see some of the prediction from the 2021 operational year. On the top, you can see the output of the risk of the disease. And on the bottom, it's the output of the models which predict the mosquito abundance, which is the mosquito population expected in different regions. These reports are disseminated through the consortium partners to the relevant stakeholders for further exploitation. Additionally, all the data and the predictions are available through a dedicated web platform. The platform has 2 levels of access, an open level for non-sensitive data and a closed level access for fine-grained epidemiological data and for model predictions, which due to their sensitive nature, they cannot be open to the general public, let's say, but only to specific stakeholders like public health authorities, researchers, etc. So going back to the significant milestone of EIWA's distinction, the following slides provide a brief overview of the communication and dissemination actions that were implemented in local and national level in order to raise awareness about the EIWA system, create the conditions that would vividly reflect the journey of this voluntary action, and establish EIWA as a brand identity that will be instantly recognized as the game changer in the domain of epidemics. Just to give you a perspective of the outreach activity, here you can see the banners developed by the European Commission for the EIWA distinction. This slide shows the press release that published for the EIWA Prize, which was distributed to journalists and social media channels. The EIWA award also attracted the attention of the media, and here we have screenshots from the articles published in the GeoBlog and the Horizon magazine. And generally, we have almost 25 published articles in local and international media including interviews in local TV. I would like to thank you for your attention, and let me have if you have any questions, or we can have it later. I think there's a dedicated section for questions. Thank you very much.
Thank you, Konstantinos. Very interesting, very good outcome, very clear, well constrained. And now we will try to launch the video. Very interesting, the video. It's quite challenging. A lot of challenging issues, and I must say that all our activity, many projects are driven by the goals and objectives of the UN Agenda on Sustainable Development and the effort of all institutions and the nations to achieve the goal of this 23rd Agenda on Sustainable Development, which is, as we know, it's quite difficult, especially with reference to energy production and waste management and protection of our ecosystem. But certainly the research can play and will continue to play a key role on this. And we will do our part, of course, and I'm sure that T-Shape will provide a very important input and contribution to policymakers and to all those in charge to take a decision at any geographical scale, from local to national, global. So as part of this webinar, now we have 10 minutes available for questions and discussion, open discussion on any matter that any curiosity driven questions related to the presentation that during this full presentation, we tried to synthesize a major outcome of all pilots involved in this showcase on health surveillance. I think it's a good starting point because a lot of tools, besides the good science that is behind them, but there is a big effort to make available the science and scientific knowledge through end user driven tools that can allow people to take advantage of the advances in and progress in knowledge and science in specific sectors. And so I leave the floor open, and so to any questions, you can use also the chat eventually. You would like to address the written questions, so we can try to provide an answer, or I will redirect the question to the expert that we have in the panel here with all the speakers. And so don't be afraid, shy to make questions.
Nicola, I don't know if
Yes.
you've seen my raised hand.
Yes, please. Go ahead. Yes.
Konstantinos, thanks for a very good presentation. What data, spatial data do you use? Mainly Copernicus services, or what is your pilot based on mainly? Thanks.
Yes, thank you very much. It's a mixture of multiple data sources. Wherever Copernicus data are available, we are using them. So we're using Sentinel-2 data for our to calculate the normalized indexes. Do you know what these are? The NDVI, etc. And we are also using the Copernicus ERA5 data to get some data related to the wind and rainfall. And also there are some other Copernicus data sources like the water and the wetness sources. So wherever there are Copernicus data, we use them, but also we are also using them some data from, for example, from Landsat 7 and 8, because Sentinel-2 only started in 2015, and our time series go back to 2009 starting. So for that period, we are also using, we need to find some different way to get the data. And also we're using the MODIS satellite, which provides the land surface temperature data. So it's a mixture because Copernicus provide, let's say, the best data and best time, not frequency, yes, frequency.
Resolution. Yeah.
Yes, like the Sentinel data have a revisit time of 6 days, while the Lancet have, I think, 15 days, if I'm not mistaken. So wherever we can find them, and they are used there. But we are supplementing with whatever else we can find.
Perfect. Thanks.
That's
You
good.
too.
So any question from the audience?
If there are no question from the audience, I have a question
Go ahead, Konstantinos.
to the rest of the people. So, at least speaking from our side, it is always a challenge to try to persuade, let's say, the decision makers that our model predictions are correct, they are working. Of course, no model is correct 100% of the time, and there are always challenges, especially when it comes to health, when it's not 100% correct. People are going to focus on this. So always trying to minimize like the false positive. But from your specific domains, do you find the same problem? Whoever from the rest of the pilots want to answer.
Yeah, I can try to answer actually to this question, because this is a very relevant question, because scientists always historically had the problem to interact with the policymakers because of different language. You need to build a trust between different entities, and sometimes when you go to policy-driven meeting, people are always skeptical about the outcome of your model and so forth, because when we talk about the policy, especially at the international scale, but the same applies also at the national scale, you need to look for consensus, of course, and you need to make sure that what you propose is accepted by all interested parties. So the best way to do it is to get involved in the expert group that are supporting the policy development. So at the European level or international level, there are a number of ad hoc expert groups nominated, designated by countries and by regions. So in that framework, you can bring the best knowledge, so including the tools, and to allow people to look into it and to become confident. And so we have been doing experience like this for the Minamata Convention, for example. And the work that was presented by Sergio on the Knowledge Hub for Mercury has been presented several times in the framework of this of the Conference of Party, but also in the framework of expert group that are in charge to do effectiveness evaluation of the convention. The same story has been done in the convention on long-range transport of air pollutants, that both POPs, mercury, but also aerosol and ozone precursor are part of this convention. So in that framework, there is, for example, a task force on hemispheric transport of air pollutant that is in charge to test different type of models, to promote modeling intercomparison, to evaluate the range of uncertainty between models and between data sets and of all kinds. So how to treat the uncertainty, because at the end, the policymaker wants to have a clear results for each scenario, policy-driven scenario, but they also ask the range of uncertainty of your average value, for example. So that's it's very time-demanding activity, but that is the way to bridge science and the policy. So to make sure that scientists spend some of their time to bring the knowledge in this policy context. So that's, and this is also very interesting for scientists, because scientists can learn a lot of things in this framework that they were not aware before. So helps to improve also your capacity to develop research project policy oriented or application oriented. So that, I think, is the aim of a good part of the Horizon Europe framework right now. So several partnerships of Horizon Europe are aimed to bridge science and the policy.
we have a advantage. I touched upon that in my presentation, because being part of the Stockholm Convention mechanism and processes makes it kind of automatic that the policymakers in the end need to consider the main outputs that the Conference of Parties, the highest decision-making body, actually approves. So they are pushed in a way, policymakers, to take our data and our work into account. Firstly, and secondly, also Nicola already spoke about it. We are using the wealth of data that we have also for in other projects that concern chemical risk assessment, for example, in the partnership which is called PARC, just launched in Paris, and in our work in European infrastructures as well. So in this sense, it's going, I would say, it's satisfactory. And on the national level, we established, as Resetox, we are helping the Ministry of Environment, and we established a science policy platform that actually gathers ministry officials and academia, and we meet every third month, every quarter year, and we actually show them where we are, what we do, and we discuss projects and we discuss inputs, and we also have the mandate to ask the ministry to perform specific tasks. So that's also in the power of that science policy body that we have on chemicals in our country.
Yeah, that's a good point, Lucas. And one thing I want to add, just as information for the audience that will be useful for everyone, that in Horizon Europe, there are 14 partnerships already approved by the Commission. And one of these is on chemicals. The PARC partnership is under Cluster 1. But there are other partnerships that under different clusters that will offer the possibility to bring the outcome of different showcase in E-Shape, but also in other European projects that have been finished, like EraPlanet, one that we have been closing just recently, and to bring this legacy in this new European research framework program. And there are different possibilities, many possibilities, I would say. And so another possibility to use Earth observation data is also under Cluster 6 in different partnerships related to sustainability, agriculture, the use of Earth observation data in agriculture to speed up the process of digital farming and the precision farming, and also the food security partnership. And so there is a lot, really a lot for scientists, policymakers, private company to get involved and to do a lot of good work. So the scope of this webinar today was just to highlight major outcome, but certainly there is a follow-up to this webinar today and to the project as a whole in this framework of Horizon Europe. So I invite everyone to open their eyes and look around, and there are different opportunities out there. So any other question? We have 1 minute left before we close the session. Any burning issue? It seems that no burning issues, so I'd like to thank all the speakers, all the 4 pilot leaders, that for the excellent work and for the effort, and also I'd like to thank all the attendees and participants to this webinar that I think, I hope that provided useful information for your everyday activity. Thank you, and see you sometimes in the near future.
Thank you. Bye-bye.
Thank you. Bye.